Welcome to the training for Mechanical Science Fundamentals, jet pumps, filters, and strainers. The average time to complete this training is estimated to be 15 minutes. After you have completed this portion of training, you will be directed to the next training lesson in the series for further instructions. These are the objectives for this course. A jet pump uses entrainment to function. Entrainment is a process by which the molecules of one fluid are carried along with a higher velocity fluid. If steam or air is supplied to a nozzle, it will increase the velocity so a high-speed flow exists. This high-speed flow carries molecules from the suction chamber along with it. This creates a low pressure in the suction chamber which draws the fluid being pumped into the suction chamber where it is entrained with a high velocity flow. This entrainment exists as long as the high velocity continues, maintaining a low pressure area in the suction chamber that continues to draw the pumped liquid. Entrainment uses a high velocity fluid to carry along molecules present in the suction chamber of a jet pump, creating a low pressure area due to the exit of those molecules. The low pressure area created, as a result, draws the liquid being pumped from its container. This process is referred to as eduction. Eductors are used to transfer fluids from one location to another without using an electrically powered pump. The advantages of eductors over electrical pumps include no priming required, no need to alter system configuration, lower initial cost, no moving parts and less maintenance required. Disadvantages include limited suction lift, more complicated operation. Jet pumps continue to be used in LWO, particularly in the tank farms, to transfer waste, move and circulate erosive slurries and corrosive liquids. The terms eductor and jet pump can be used interchangeably. The jet pump uses high-pressure steam. This can be used to transfer fluids such as water, waste, or gases. In some cases, gases are often removed to maintain a vacuum in a vessel, such as a condenser. To keep many of our systems operating properly, we must have the ability to remove impurities from the liquids. This is done by the process of filtration. Filtration can be accomplished using strainers to remove large particles, or if small impurities must be removed, we can use filters. They can both be used in a system. For example, a swimming pool has a strainer in the return line and a filter near the pump. A typical filter used at SRS is a cartridge filter. The cartridge is a perforated metal cylinder with a fiber yarn wound around it. The liquid being filtered is forced through the yarn, which is approximately 1/2 inch thick, and then through the perforations in the metal core to the filter outlet. A cartridge filter may include one or several cartridges. The number of cartridges depends on the liquid flow rate that must be handled. Liquid is pumped from the system to the filter. As liquid enters the filter, it surrounds the filter element and flows through the fabric. As the liquid flows through the fabric, the solid impurities are trapped in the material. The filtered liquid continues to the filter outlet and returns to the system. This is the same concept used in the oil filter in your car. The differential pressure across filters, inlet to outlet, let the operator know when a filter is becoming plugged and must be replaced. When the cartridges are removed from radioactive systems, the radiation levels can be very high and must be handled according to approved procedures. The advantage of a cartridge filter is that they are self-contained and can easily be replaced and disposed of. The disadvantage is that a stock of every type of cartridge must be maintained on site because many cartridges are not interchangeable. Deep bed filters are usually found only in makeup water systems where they are used to filter water after it has been treated. They are used to remove organic matter, chlorine, and very fine particulate matter. A deep bed filter has a support screen which is mounted a few inches above the bottom of the tank. The screen is perforated to allow water to flow through it. A layer of coarse sand, crushed rock, or charcoal is placed directly on top of the screen. The deep bed, consisting of 2 to 4 feet of granular anthracite or charcoal, is placed on top of the sand. The filter is sized so that there is 1 to 2 feet of free space above the deep bed. When the filter is in service, water is pumped through a distribution pipe above the deep bed. The water is filtered as it percolates down through the granules. Charcoal granules will filter out organic matter, chlorine, and fine particles, while anthracite granules only remove the particulate. The water collects in the bottom of the tank below the support screen and leaves the filter through a pipe in the bottom of the filter vessel. Deep bed filters are cleaned by backwashing. Water is pumped backwards through the distribution piping near the bottom of the filter. The flow rate of the water is kept high enough to lift the granulated charcoal or anthracite up into the free space. The water washes away the deposits that have accumulated. When the backwash cycle is completed, the flow is stopped, the granules settle back down onto the filter bed. The filter can then be put back into service. Strainers are installed in many piping lines to prevent the passage of grit, scale, dirt, corrosion particles, and other foreign matter which could obstruct pump suction valves, throttle valves, or other machinery parts. The Y strainer operates on the principle that as a fluid with entrained particles attempts to flow through the screen that makes up the inner part of the strainer, the particles are trapped in the screen and fall to the bottom where they can be removed. The advantage of these strainers is that they are easy to clean. The strainer is isolated and the nut holding the screen in place is removed. The strainer can then be cleaned and returned. The nut holding the screen in place is replaced and tightened. Then the strainer can be unisolated and placed back in service. The disadvantage of this type of strainer is that it can only be used to remove relatively large particulate matter. Duplex strainers are used in fuel oil and lubricating oil systems where uninterrupted flow is essential. Duplex strainers include two strainer baskets. Only one is placed in service at a time. The other side of the strainer is clean and on standby. When time to clean the on-service strainer, flow is shifted to the basket on standby. The strainer basket that was on service is cleaned and replaced in the strainer body. It is now clean and on standby for when needed. During regular operation, one basket is on service and the other basket is in standby. When the in-service basket needs cleaning, flow is shifted to the standby basket. That side basket is then drained. The used strainer cover is removed, the strainer basket removed, cleaned and reinserted, and the cover reinstalled. It is now on standby until the next cleaning is needed. Bucket strainers are located in the pump suction line between the suction manifold and the pump. They get their name from having the shape of a bucket. Any debris that enters the piping is collected in the strainer basket. These are used a lot when the water is from a dirty source, such as a lake, pond, or river. The basket can be removed for cleaning. This is a type of combined strainer that is desirable where space is limited because it eliminates the use of separate strainers and their fitting. The manifold has one large strainer basket similar to other types of strainers and is upstream of lines that branch off. The cover is located so that the strainer basket can be removed for cleaning.